Okay, students, we have done about the methods of preparation of alkanes. You have got 5 methods, and in exam, the reaction may be asked or any one method asked like this: how will you prepare alkane by applying Wood's reaction? How will you prepare alkane by electrolytic method? That type of question you will get from the methods of preparation. And there are a number of questions. I'll give you the idea of questions after completing the alkane chapter. So now we'll do physical properties of alkanes. Now I'll give you the physical properties point wise. Physical property means what about the boiling point of alkanes? Alkanes are soluble in water or in other compounds. Alkanes exist as gas, liquid or solid. This type of properties are called physical property of alkanes. So if you want to know about the physical properties of alkanes, the C1 to C4 alkanes, C1 to C4 alkanes, they exist as gas. C1 to C4 means, the alkane which contain 1 carbon to 4 carbon, that type of alkanes are called exist as gas. Methane, ethane, propane, butane, they exist as gas. And C5, 5 carbon to 17 carbon alkanes, they exist as liquids. Pentane, hexane, heptane, octane, that type of alkanes exist as liquid. And higher member alkanes, 17 carbon onwards, higher members, they exist as solids. So alkane may exist as gas, it may exist as liquid, it may exist as solid. Normally smaller alkanes, they exist as gas. Methane, ethane, propane, butane, it exists as gas. And from pentane onwards, they exist as liquid. And the alkane which contain more than 17 carbon, you will get as solid. In solid state, you will get that type of alkane. Higher members are all exist as solid. This is one point. Second point, since alkanes contain only carbon and hydrogen, and due to presence of carbon and hydrogen, there is no electronegativity difference between carbon and hydrogen, and due to similar electronegativity of carbon and hydrogen, alkanes are said to be non-polar. Non-polar molecule. Polar molecule means those molecules which have some electronegativity difference between atoms. For example, if you consider HCl molecule, as you know, chlorine is highly electronegative than hydrogen, then chlorine will form delta minus, hydrogen will be delta plus. This type of molecule which can produce two pole, positive pole and negative pole, they are called polar molecule. But in alkane, as you know, methane, alkane contain only carbon and hydrogen, and due to presence of carbon and hydrogen, there has no such difference in electronegativity between carbon and hydrogen, and due to less electronegativity difference, they cannot produce this type of delta plus and delta minus, and that is why alkanes are said to be non-polar molecule. So this HCl is said to be a polar molecule, and this methane or alkane is said to be a non-polar molecule. So since the alkanes are non-polar, that is why alkanes are insoluble in water. As you know, water H2O, it is a polar molecule. Due to presence of oxygen, as you know, oxygen is highly electronegative, so oxygen will form delta minus, hydrogen will be delta plus, and due to this electronegativity difference, water is said to be a polar molecule. Normally water always used as solvent. Since our solvent is polar, alkane is non-polar, that's why it is insoluble. There is a rule which is called like dissolves like, and according to that rule, if your solute is polar, solvent should be polar. If solute is non-polar, solvent should be non-polar. So since alkanes are non-polar, that is why it is insoluble in polar solvent. So if you want to dissolve alkane in some solvent, then you have to take some non-polar solvent. Non-polar solvent example, benzene is one example of non-polar solvent. Carbon tetrachloride CCl4 is one of the example of non-polar solvent. And that is why if you want to dissolve some alkane then you have to dissolve the alkane in benzene or carbon tetrachloride. You cannot dissolve in water. So the second point is, since alkanes are non-polar, that is why they are insoluble in water. So alkanes are generally soluble in non-polar solvent like benzene, carbon tetrachloride, etc. So if you want to write second point, since alkanes are non-polar, so they are insoluble in water. Insoluble in water. Alkanes are soluble. Alkanes are soluble in non-polar solvent. In non-polar solvent like benzene, carbon tetrachloride, CCl4, etc. So this is about the solubility of alkane. If you want to dissolve some alkane like methane, ethane, propane, butane, if you want to dissolve, then you have to dissolve in non-polar solvent. You cannot dissolve in polar solvent, and that's why it is insoluble in water. Number 3, what about the boiling point of alkanes? If you want to compare the alkane boiling point with some other compound like alcohol or some other compound like aldehyde, ketone, then normally alkanes have lower boiling point than the alcohol. And why alkanes have lower boiling point? Due to its non-polar character. Actually, alcohol, due to polar character, alcohol can form some hydrogen bonding between the molecules, and those organic compounds which can form hydrogen bonding, they have always higher boiling point. And in alkane, since there is no such electronegativity difference, since alkane is non-polar, that is why alkane cannot produce any kind of hydrogen bonding, and that is why the boiling point of alkanes are low, comparatively low boiling point. Now, if you want to compare the alkanes like methane, ethane, propane, butane, which one have more boiling point? If you want to compare them, suppose this is methane, CH4, this is ethane, C2H6, this is propane, C3H8, and this is butane, C4H8. If you want to compare their boiling point of butane is more than propane, more than ethane, more than methane. This is the boiling point order. Why the butane have more boiling point than propane than ethane? Actually, boiling point depends on the mass of the compound. Depends on mass of the compound. As the mass of the compound increases, the boiling point also increases. Since butane contains 4 carbon, that is why its molecular mass you will get more. As the mass of the compound increases, its boiling point also increases, and that is why butane have higher boiling point than propane, than ethane, than methane, like that. And in case of isomers, in case of isomeric alkane, you know isomer means same formula but different structure. For example, this is one of the alkane, CH3, CH2, 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 CH3, 5 carbon present. This is called pentane, normal pentane, no branching here. And this is one of the compound which contain branching. It also contain 5 carbon total, and the name is 2-methyl butane. 2-methyl butane. And this is one of the compound which also contain 5 carbon. Which also contain 5 carbon. Its name is 2,2-dimethyl propane. So these 3 are alkane, and if you want to compare about their boiling point, since their formulas are same, you will get same mass of these 3 compound. You know, boiling point depends on the mass of the compound. If mass is more, boiling point is more. But in case of isomer, they have similar formula, that is why they have similar masses. Now what about the boiling point? Their boiling point will be same or different. As you know, isomers means those compounds which have similar formula but their properties are different. So although they have similar formula, although they have similar masses, but their boiling point are different because their properties are totally different. In case of isomeric alkanes, straight chain compounds have more boiling point than the branching one. I mean, as the branching increases, its boiling point going on decreasing. And why? Because although their masses are same, but due to their structure, see, this is straight chain compound, this one contain one branch, this one contain double branching. As the branching increases, the surface area of the molecule going on decreasing. In case of straight chain compound, the surface area will be more. As the surface area increases, boiling point increases. So boiling point depends on two factors. It depends on mass and it depends on the surface area of the compound also. It depends on surface area. Greater the surface area, greater will be the boiling point. As you know, when double branching takes place, then the molecule will adopt like a spherical shape, and spherical shape have lower surface area, you know, and due to this lower surface area, 2,2-dimethyl propane have lower boiling point. So that is why if some isomers are given, isomeric alkanes are given, then the boiling point depends on the surface area of the compound, because isomers have similar masses. If you get similar mass, then you consider the surface area, and if the compounds have different masses, then higher molecular masses compounds have higher boiling point. So when you determine the boiling point, and if you want to arrange the molecules in order of their boiling point, then you have to arrange the boiling point depending on their mass and depending on their surface area. And these are the physical properties of alkanes. Thank you.